Welcome, everyone. Today is going to be a fun workshop on building an internal developer platform based off of the Backstack. So let's introduce who's here with us today. Anna?
Hey y'all, I'm Margarita Medina. I'm a staff developer advocate at Upbound, and I also sit on the Kubernetes Code of Conduct Committee.
Awesome. And Christian?
Yeah, so Christian Hernandez from Cisco Isovalent, technical marketing. I'm also Argo CD contributor maintainer.
Awesome. Courtney?
And my name is Courtney Nickerson. I am head of community at Nirmata, the creators of the Kyverno project, and I'm also a CNCF ambassador.
Awesome. And I'm Scott Rosenberg, lead architect in the CT office at TeraSky, and a platform engineering ambassador. So awesome. And today we're basically going to go over a bit of slides at the beginning, intro to platform engineering, intro to the projects we're dealing with. Then we're going to do a hands-on guided workshop where we'll go through really building out the platform and going through the different use cases. There's some free time as well. There's guides with documentation in the labs for everyone to play around. We'll be walking around if there are questions and everything, and then a wrap up at the end. And yeah, really the projects we're talking about today is the Backstack, right? Backstage, Argo, Crossplane, and Kyverno. And this is basically going to be our cornerstone for building this internal developer platform. But simply because of conference Wi-Fi and everything, we're going to start with something before we talk about the projects, which is if people go to this GitHub repo here, scan the QR code with your computer if you want, or just go to the URL or the shortened URL. What you're going to do is you're going to fork that repo, and then basically you want to start a code space. So in order to do this, just fork the repo, and then open a code space. I'll do that on the screen as well, just to, do I do that? 1 second, duplicate screen. Switch to the right user here. Yeah, and you're basically just going to want to fork it. And then just on the code button, you can code spaces, open in code spaces. Do not just create the code space. Actually do the 3 dots with new with options and select the 4 core option. Everything we're doing here will fall into the free tier of code spaces, so no need to worry. I do recommend people that have a credit card set up on their GitHub account to shut this off, to tear down the code space at the end of the workshop. Otherwise, your credit card may be billed heavily. So just change this to the 4 core model in US East and create that code space. This is just going to take about 15 minutes in the background to do the download and setup. So once we get this set up for everyone, you know, this will happen in the background as we go through the slides here. So people can do that, and let's go back to. You
want to put the code up again?
Yeah, he's going to.
Exactly.
There we go, yeah.
So that's the URL again. I'll give everyone just like 2 minutes to do this, and then we're going to continue on to the projects.
Should have had music or something playing while. Some like background.
Some lo-fi beats?
Yeah, yes, and some lo-fi, yeah, something to get them concentrated.
Exactly.
Yeah.
Or some like Jeopardy music.
Yeah, Jeopardy music or.
Yeah, so when you do the new with options, what you want to change is by default it's going to be 2 cores. You want to change that to 4 core. Spinning up the entire Backstack does take about 4 cores to make it actually perform normally in a constrained environment. Spinning up an entire Kubernetes cluster and a bunch of stuff in it.
It takes a little while. So we're having you do this in the beginning, and then while you're waiting, we'll go through what every component does.
Exactly.
All right.
And GitHub Codespaces does have a desktop version as well as web. We recommend using the web version here. It's much easier to get working and all of that, and there's some less quirky behavior when you use GitHub Codespaces in the web browser. So that is the strong recommendation, I would say. But awesome.
Yep.
Awesome. So let's start, and we're going to start this time in the order of the backstack. So we're going to start with Backstage. So let's talk for a moment on what Backstage is, right? Backstage, there is a common misconception and lie told that Backstage is an internal developer portal. That's an absolute lie. It is a framework for building an internal developer portal. And that's very important to know because it's not a product. There are products that exist out there. Some of them have booths downstairs that deal with these things for us, that build internal developer portals as a product. Some of them are even based off of Backstage. But Backstage is a framework that allows us to add our own plugins and to really customize it to what we want our portal to look like. It is powered by a central software catalog. And this really is about bringing back order and really trying to bring order to the chaos of the IT landscape within all of our organizations these days. Right? If we really try to sum it up, a developer portal is one front end for your entire infrastructure. And that's really the idea here. Now, if we take a look at Backstage, right, what is it really all about? Backstage is about letting any developer do a few things. Number one, create new software in seconds aligned to your best practices using a tool called the software templates or the scaffolder to manage all the software that we own in one centralized location as well. Also to explore our entire software ecosystem, right? To enable really that collaboration across our organization. One of the biggest challenges is, oh yeah, I created another module in Terraform of a VPC, and now we have 37 because I didn't know about the other 36 that already existed. And having this exploration and knowing what exists is really important, right? Backstage has a very customizable and extensible plugin architecture with both front-end and back-end plugins. I will say it is not for the faint of heart if you do not know JavaScript and TypeScript and React and all of that. But the good thing being based off of those frameworks is that they are common knowledge within. There are a lot of people that have them. This isn't using some esoteric language that is difficult to deal with, but it does require TypeScript and React knowledge to really get running. When we look at really the key components, it really starts with this software catalog, which is where we can see all of our different components, who owns it. We can create hierarchies of which system a component belongs to, which resources, dependencies, APIs, things like that. We can go into our components themselves and get this visualization where we get resource graphs of dependencies, of what relies on what, things like that. Links out to technical documentation, to the source code. We also have software templates, right? This is where we're able to click on a template, fill out forms of what we want, and have some type of action run in the back end, usually scaffolding of a new GitHub repo, something like that with things, but completely customizable, and we're going to be going through that in the workshop as well. We also have API documentation, right? So we have the ability to get all of the APIs of our services documented here and linked up to our components, making this really discoverable and easy, as well as technical documentation. Right here you can see just an example, the entire Backstage documentation hosted within Backstage, right? Which is a really powerful thing that we can have our documentation living alongside our components and everything visible from one place. It's used at a lot of companies. It's used across every industry. It's the, if I remember correctly, the 11th most contributed to project in the Linux Foundation, let alone the CNCF. It is a hugely widely adopted project. And really when we look at the ecosystem, there's over 250 plugins in the official marketplace. There's 100 plus plugins in the community repository, which is like a community repo owned kind of by the Backstage community itself. Obviously we have, well, there's no Backstage plugin because it's Backstage, but the rest of the Backstack has plugins. so the ACK stack. And here's just a few of the other common ones that exist, right? And common tools in the Kubernetes space, in the DevOps space, things that we have in our environments, be it the cloud, CI/CD tools, source controls, secret managers and security, cost optimization tools, monitoring, right? Really the whole plethora of things that make it an extremely powerful thing, and you can always build your own plugins as well. Just a few key things that have changed. We have the new front-end system is now GA. We're going to be using that here. What this means, and the reason this is important, is that people have looked at Backstage as, oh, it is so difficult just to maintain it. I need to know React. I need to know all of these things. To integrate a plugin that you didn't write was knowing a lot of React to hook things up. That's not true anymore. Yarn install, you literally add a dependency, and boom, it's in Backstage, because we have the ability now with this new front-end system making basically a no-code integration of plugins possible, which is extremely powerful. Backstage can now be used as an MCP server. Obviously, we need to talk about AI because it's 2025, so there will be AI in the workshop as well, because, you know, otherwise there's no money in anything today. We also moved from Webpack to RSPack for packaging up Backstage. This is a major change. It makes the build times much faster. So really, it's a great thing with basically no bad sides to it. And the documentation site is being revamped to make it easier to get started and to find what you're looking for. I apologize for anyone that has tried to figure out what they're doing in the Backstage documentation, but it's getting a lot better. So I'm going to pass it off now to Christian to talk about Argo.
Awesome. Thank you. Appreciate it. All right. I'm going to talk about Argo, brief introduction to Argo, you know, what Argo is, right? So Argo in general, right, is a suite of DevOps tools for Kubernetes, right? So a lot of people, when you say Argo, when you mention Argo, the first thing they think about is Argo CD, right? But it's actually the Argo project is made up of 4 tools, right? It was originally developed at Intuit. Intuit made the strategic decision to go all in on Kubernetes. So no more VMs, no more cloud instances, everything on Kubernetes. Everything cloud native, but they had no way to on-ramp their applications onto Kubernetes, right? There was, at that time, they were very, very early adopters. So they created these tools and then to help accelerate their adoption of Kubernetes. And so they created these tools and they later donated it to the CNCF, right? So the 4 tools are Argo workflows, we call them the big 4, right? The Argo workflows, Argo CDs, Argo rollouts, Argo events, and I said 4, but there's a secret 5th one that we call Argo Helm, right? So, and the reason why we don't really call it one of the big 4, but it is an official project, is because that is the official way to install Argo, is using the any one of these tools is to use the Helm chart. It is managed and maintained by the entire community, people from Intuit, Red Hat, Acuity, you know, all the other major players. They actually actively maintain that, right? And so anytime someone asks me what's the official way to install Argo, it's Argo Helm. So too long didn't read, right? For the background of Argo is that Intuit went all in on Kubernetes and just needed tools to manage their production workflows, right? But you're not here to hear entirely about the whole ecosystem. We're going to talk about Argo CD, and I like how that rendered not very well. It looks like I'm going to talk about Argo rollouts. So the conversion, right, between slide. So Argo CD, at its core, it is a GitOps tool, right? And so, and for those of you who don't know, there are actually 4 GitOps principles, right? If you go to opengitops.dev, you can read all about it, right? Argo CD basically conforms to the GitOps principles, right? Something that's declarative, something that it takes its configuration from its storage that is version and immutable, right? So something like Git is version immutable, S3, Helm, right? All that's good stuff, OCI. It's pulled automatically, right? Meaning that it doesn't rely on an event, right? It's not an event-based system, right? It basically runs every 3 minutes to check if there's a change in your source of truth, right? In Git. It's continuously reconciled, right? I said that like the 3 minutes type of loop, right? So when I say loop, think about like control theory, right? Closed loop systems. I always just say, what is GitOps? GitOps is a thermostat, right? So I remember my first apartment, right and going to college, had like those wall mount air conditioners. When it got too hot, that was an event, right? I got up, I turned it on. When I was cold enough, that was another event. I stood up and I turned it off. Whereas GitOps acts more like a thermostat where I set my desired state, right? I set it to 72, or if you're from Europe, 20. And the thermostat continuously monitors the ambient temperature and turns off and on when it needs to, right? That's GitOps in a nutshell. What Intuit used Argo CD for is really an application stack deployer. And so really it looks at Git for changes, and it'll synchronize the manifests for your application onto n number of clusters, right? However many clusters you attach to it. It's a hub and spoke design. So when you think about your application in terms of Kubernetes, right? Your application is made up of kind of loosely coupled objects, right? You have like a service, you have a deployment, maybe a stateful set, maybe a persistent volume claim, maybe a gateway API, HTTP route. They're all kind of loosely coupled with labels, right? So Argo CD allows you to manage your entire stack, right? Because your application is made up of, a mountain of YAML, right, that you have some sort of, but you can manage it as like kind of a single entity. And it's not just Git, right? We say GitOps because it's, it was catchy, it's kind of earwormy, but it actually supports things like Helm, right? Like it'll go and pull things from Helm, from Git, obviously, from OCI, or like from Customize, right? Like if you have like a Customize, it'll automatically detect you using Customize and it'll render those out. OCI, I actually did a talk yesterday about OCI and Argo CD, so if you're gonna look at the recording from ArgoCon, I did a talk about that. And while Scott's standing here, a Flux person, right? So I do want to address the elephant in the room. Like one of the things that I get asked a lot. I've been in the GitOps ecosystem for a long time now. I was like, well, what's the difference between Argo CD and Flux, right? Really, like it's just nuance, right? Because both projects approach the same problem from a different angle, right? Weaveworks developed Flux internally, and they wanted to keep the lights on. They wanted something for their DevOps engineers to be able to deploy and manage their Kubernetes clusters. On the Intuit side, they wanted something that's developer-friendly to be able to deploy applications and adopt Kubernetes, right? So they saw the same problem. They kind of solved it in a different way. But at the core, they're actually very, very similar. They're both GitOps tools. They're both GitOps compliant. They both do a lot of the same thing. But kind of just some of the things here. Argo CD, they started from the UI down, right? So they created a UI because it was for their developers. Flux, you need to get a UI from like third parties, right? Argo CD is actually built as a monolith, right? For better or worse, it's built as one big application, right? There's different controllers and things like that, but it's built like a monolith, right? You can't take those individual pieces and use them. Whereas Flux was built on the GitOps toolkit, right? A series of libraries and controllers that you can actually use independently. You can actually use Flux as a library for your, basically the GitOps toolkit, right? There's like a toolkit that you can use. And Flux is just an implementation of the GitOps toolkit, if you can think about it that way. Argo CD implements its own RBAC. This trips up people a lot. This is actually a point of contention, is that Argo, it manages its own RBAC. And Flux just uses whatever Kubernetes does. Is basically, it uses the Kubernetes RBAC system. Argo CD, for better or worse, emulates kubectl as much as possible. We talked to the Intuit guys, that was kind of like their core philosophy, is like, okay, we want to emulate kubectl as much as possible, even with all its kind of unexpected side effects. Even if it doesn't make sense. And it uses raw YAML. That's another thing that Argo CD does, right? If you do it Helm LS, On an Argo CD system, you won't see anything even if you're using Helm charts, because Argo CD will render those out and will apply those as raw YAML. The decision was that for like, it didn't want to write a controller for each implementation, right? Like it wanted to always use raw YAML. And Flux uses the standard libraries, right? It uses the Helm standard library, for example, to deploy Helm charts. Support for SSO integrations, right? SSO for Flux is really only third party. I think Crossplane has put a lot of work into that. And you can extend it for other config management tools. Right, like if you're using QLang, I get, but I think maybe QLang, no one's using it anymore. But if you have like another config management tool that you would like to use, Argo has a plugin system. And extending other config management by the Flux core is not currently available. So kind of very, very nuanced, right? But at the core, it does the same thing. And so I do want to end my portion for a shameless plug. I wrote a book on Argo CD. It's sponsored by Acuity, so thanks to Acuity sponsoring the book. I'm doing a book signing tomorrow, so if anyone wants a hard copy, they have it at the Acuity booth tomorrow, free hard copy. But if you won't be there or are doing something else or watching this later on, go ahead and scan that QR code and you get a free PDF copy. So, and I think with that, I am going to pass it on over into, to learn a little bit more about Crossplane. What's that? What's that?
Send an email to you or PDF copy?
No, you just scan it. You should be able to fill out the form and it'll email it to you. Oh, sorry. You have your mic.
Thank you. Hey, y'all. I'm going to be doing an introduction to Crossplane. If y'all don't know, Crossplane is a control plane framework used for platform engineering. We know how Kubernetes is based on control planes. Well, Crossplane extends Kubernetes to manage any resource anywhere. So you can think of that as like resources that you have on the cloud, third-party resources, as well as anything that you want to create custom on-prem resources also applies. So we get to see that we get to use a declarative model that Kubernetes is known for, along with that reconciliation loop, and really put like Kubernetes as the center of a way of building your platform. Sometimes Crossplane gets grouped together with infrastructure as code, and I like telling folks that you're building a platform instead when you're comparing it to other tools like that, because you get to base on the reconciliation. This allows for platform teams to expose infrastructure and application APIs for developers. So if you have heard of Crossplane in the past, maybe you've heard of Crossplane before 2.0, where it was mostly focused on infrastructure. With Crossplane 2.0, we're really extending that and letting folks do infrastructure and applications within their control plane. And we're also a newly CNCF graduated project as of last week. So we've gotten a chance to have over 100 million downloads. We have contributors from over 450 companies, and we have folks from many companies contributing and adopting. When you want your developers to use Crossplane, they get to use it through a developer portal, like we're going to be doing today with Backstage. You can leverage, like your developers can leverage it via console or just CLI on its own. So when someone is using your API, they get to just request a composite resource, and this composite resource can actually create Kubernetes objects. They can create managed resources on the cloud, or they can create any third-party resources that you also want to do. We see some logos of some Crossplane adopters. There's like 67, I think, that have like publicly talked about their adoption on the adopters markdown page if you want to take a look. But being used in production worldwide across many, many industries. And wanted to go over some of the Crossplane concepts that you kind of will get to see in this workshop today. First, we have managed resources. These are the Kubernetes representations of the resources that you are managing with Crossplane. Then behind that, we have composite resource definitions. These are the blueprints of your APIs, basically the schemas for your composite resources. And then the compositions are going to be defining which way the resources are going to be created and how. And then we also have packages, which that's the extension of Crossplane, where we have providers that allow for you to connect to like AWS, GCP, Azure, Kubernetes, and other things like it. Then we also are allowed to extend the logic of when you're building all your compositions. You can do this in your preferred language as like Go templates, KCL, and Python. You'll get to also see that on the GitHub repo that we've documented that. And when you're ready to version the way that you're offering your platforms, you can leverage configurations. These are ways that you can allow folks to use your reusable resources at scale. And with Crossplane 2.0, we've also introduced operations. These things keep things running smoothly over time, whether it's rotation of credentials, rotation of keys, and backups, and anything that's like scheduled maintenance. And then the resources that your developers are going to be using and like requesting are composite resources. These are just a single Kubernetes object based on the composition that you have written. In the past, before Crossplane 2.0, you may have heard of the term claims. That's no longer something that we're going to be using in Crossplane 2.0. So we're enabling self-service through APIs that allows for platform engineers to give reusable abstractions to folks in your company to leverage cloud infrastructure, on-prem resources, third-party services. Developers are just going to be requesting those composite resources through YAML files. You can maybe abstract the YAML files through something like Backstage. And then this is going to integrate with GitOps, with Argo CD, and Flux being something you can do. You can also integrate with portals such as Backstage and do policy with things like Kyverno and OPA. And with that, I'll pass it over to Cortney to talk about Kyverno.
Thank you. Great. So let's talk about Kyverno. I'll try to be quick because I see time ticking, and I want to make sure that everyone has time to get through the workshop. So Kyverno is an open source policy engine built specifically for Kubernetes in the beginning, but now you can also leverage it on JSON payloads. It leverages declarative YAML, and recently we had a release that added cell policy-based types also. So if you're not familiar with Common Expression Language, it's also been adopted by Kubernetes as of late. So very interesting things going on there. Kyverno also helps you manage your full resource lifecycle, as well as integrate reporting, fine-grained expectations, and it was, again, built specifically for Kubernetes, so you're going to see the power of that in our workshop today. You can see, if I change this slide, there we go. You can see we have a lot of very big adopters within our community. Our project has actually been around for almost 10 years, and so we have very large enterprises that are using our policy engine at scale, but we also have a very active community. So again, tomorrow, if you're interested in getting involved in contribution to a project like ours, we do have a Contrib Fest session. I think some of our other projects might have them as well, but please do join into those so you can learn more about our project and meet other users to get other questions answered. Quickly, what is policy as code? Policy as code is a way to leverage policies specifically in the same way that you do with code. So it gives you declarative rule definition. It allows you to write your policies in a format that's easily readable by humans. It makes it much more accessible for your developers and your operations teams in order to be able to use them and understand the power that's coming from them and have actionable ways to make things better and more compliant. It also integrates version control, which is very important, and one of the reasons that we do function very well with tools like Argo CD, because you can store, review, and version your policies exactly like you would your application code. It also automates enforcement for different things, not just security, but resource management, CPU limits, naming conventions. You don't have to use policy just for security applications. You can use it for just about anything that you need to set a guardrail on to help your team become self-service. And finally, it makes all of your deployments more consistent and auditable, so you achieve you can reproduce your applications and your deployments in a much more efficient way. So why do policies matter? They matter because they allow you to standardize things at scale very easily. They're going to make things more consistent, which we already said. You can make things a much more safer development environment for your team, and they can self-service because they now know what they're allowed to do and what they shouldn't do. So it reduces context switching and makes things a lot easier on them to know what they can and can't do. It eliminates bottlenecks above all, because now they don't have to ask for permission for things. They automatically have things in place that are set up for them. And it provides governance without friction. Nobody really wants to have to talk about governance, and so this is a very easy way to, one, not have to talk to your security team because nobody wants to do that, and also not have to talk to your compliance team. You just give them a report because also nobody wants to talk to those guys either. Let's be honest. None of us want to talk to them. Quickly, our architecture, we are an admission controller, so it runs at Kubernetes admission. It intercepts your API request before your resources are actually persisted to, et cetera. Then the policy engine itself works by webhooks, which pass that request onto our Kubernetes policy engine. It applies either validate, mutate, or generate logic there based on whatever policies you've put into action. And then it is a background controller that allows for cleanup of your operations and then provides policy reports. We have our own reporting, but we also have a side project that we collaborate with other open source tools and policy engines called Open Reports that you can leverage with Grafana, Prometheus, or any other reporting provider that you need. There's quickly our architecture from our documentation. As all architectures, it's beautifully designed. Common use cases for policy. Most people think of policy as only security, and that's great. You can use policy, and you should, for security, but you can also use it to better your operations. You can use it for cost management. As silly as this sounds, most devs are shipping their things, and they put a very high CPU limit because they just want it to work. And then you have an SRE that has to go through and figure all of that out, where you can just set a CPU limit that's actually what you need, and it cuts your costs exponentially right from the beginning because people know what the CPU limit is. This is a very simple use case that saves a lot of money for a lot of our end users very quickly. Security is clear. We obviously have a lot of security use cases. Specifically right now, a big one is software supply security, supply chain security. Validating image policy is something that everybody that's adopted Kyverno typically uses because you can set what libraries people are pulling images from and make sure that they've all been signed with cosign or SIGST or whatever it is that you're using, and that automates your security. So if anybody didn't hear his question, he's asking if we're a framework provider that has a framework that's going to give you policy for operations, cost management, security, and automation, correct? So we're not actually a framework provider. You can pick and choose all of the policies, you create them yourself, because obviously everybody's going to have niche situations that they need to adopt to their own environment. What we do have is a library of policies that actually cover all of these use cases, plus quite a few more. More than 400 policies that our community maintains on its own that you can go through the policy library, find something that fits for the use case that you have, copy it, adjust it to what you need, and use it. And we do maintain all of those as a framework. It depends on how your team is actually set up. In some cases, you have a platform team. The platform team determines what policies are going to be used for each one of those things. Other people have their security team creates their own security policies, and they have a team that's working on resources, or their SREs oftentimes create policies that are geared more toward resource management. Operations, oftentimes you have a team leader of some sort that decides what policies to use. And then sometimes there's a group of people that just manage the policies for everyone to provide those golden pathways. So it very much depends on the size of your company, the industry that you're in, how compliance checks are set up, if your focus is more on governance, if your focus is more on compliance. And to be honest, most people start off with 3 or 4 policies that are very much security-based, because policy is kind of a heavy lift and you have to get people used to having them. They start off with something really small, and then that expands very quickly because they start to realize, oh, I have a bunch of other use cases. And so that might be, okay, I'm passing this information off to another department so that they can use it, or another team. Or it might be that they just start creating more policies within their pipeline as new use cases come up. I'm going to continue. We can talk. I'll come talk to you, and we can continue the conversation so that we don't run out of time for the workshop, okay? Great. So finally, main takeaway, and we'll wrap it up here so we can get started. Kyverno makes policy writing very simple because it's in a declarative language. It's very simple to get started with it. They're super powerful. They execute 1,001 use cases, which I'll continue to discuss in just a moment with him. They future-proof all of your infrastructure and make everything much more self-service oriented for your dev team by giving them actionable ways to fix whatever it is that your guardrail is putting in place for them. And with that, I will pass it off to Scott to get started.
Awesome. So let's get started with, done with slides, let's do the interesting things. So let's duplicate screen, and let's YOLO this. Hold on.
Does anyone else need the QR code that came in late for the GitHub repo? Scott, do you want to put it up for just a second?
The QR code. You know, 1 sec. Find that somewhere. Right there.
Thank you.
Okay. So
Yeah, you can find it in the backstack GitHub organization.
Exactly.
Yep.
Awesome. So basically, now that we have our environment up and running, this basically went and installed the ACK stack. It did not install Backstage for us. That we're going to do here during the workshop itself. I do recommend people that are using Chrome and whatever, there is this install code spaces button that kind of starts up at the top. If you click on that, it's just going to open it in like a web app that's a bit easier and nicer to use. The functionality is the exact same. Just looks a bit more like an IDE and isn't in a browser tab. With that, let's get started here with the actual workshop. So we can see here, basically, we have these instructions for setting it up. We're going to go with the web IDE implementation here. And there's 2 things that we're going to have to create now on GitHub. If you have a personal access token, awesome. You can use that. Otherwise, you can just follow the link here to create a personal access token for your user. Yeah. Just give it a name. I'm very professional there. Yeah, y'all can feel very, and this is going to be deleted and it's on a fake user, so there's not much that you can do with it. But I'll do this live here just to show everyone. We're just going to create a nice little one here. That should be good enough. Generate token. And I've got my token. And we just want to copy that off to the side here. So I'm just going to open up a new file and just throw it into there for a moment. Text. That's fine. Just throw this into here. That's our personal access token. And the second thing that we're going to have to do is create an OAuth app. And this is how we're going to enable authentication with GitHub directly to Backstage. So what we're going to do is click on this Create GitHub OAuth app. And this is going to take you to this Register a New OAuth app in GitHub. In order to get the values for this, all you need to do is right under that in the README, there is this kind of section here. You can just paste this, copy it, and paste it into the terminal. And this is going to basically give us 3 different lines. The application name, it can be whatever you want it to be, the application name. But what really matters is this homepage URL and the authorization callback URL. Those 2 have to be set correctly. So just copy them. Yeah. Hold on. How is that? Is that better? Size-wise, hopefully.
But, oh, by the way, we're walking around, so if you need any help with anything, just feel free to raise your hand. I know some have been helped already. But if you have any questions or anything or get stuck, we're walking around there. Oh, I see you. I'm coming.
Okay, so what we're going to do is copy these values out. Once we have them, we just fill them in here for the authorization callback URL, give it a name, the home page itself. And with that, we can enable device flow and then register our application. This is going to create a new GitHub app for us. What, to light mode? That's a good question. I don't even know how you do that. 1 second. Can try and figure that out. Never used light mode in my life. 1 second. There's some way here. No, but this is in code spaces. I'm not sure how. I don't know how you do that in VS Code. Upper left? Preferences, settings, oh, themes. Color theme, maybe? That, there we go. And light Visual Studio, I guess. Whoa. Yeah. Okay, I guess we'll work this way. Hopefully this helps people and I don't go blind. Awesome. So with that, we've added in our things. I hope that helps. We'll be done in the web browser in 1 second, so we won't see the darkness here. We have our client ID, which we want to copy, and all we want to do is generate a new client secret. So you're just going to click on Generate a New Client Secret, and we're going to copy that value as well. And we're just going to throw those into our text file for a second. So we have our personal access token, we have our client ID, and we have our generated client secret. These are the 3 things that we need to generate that are going to allow us to render everything we need to install Backstage. So now that we should have those, all that we're going to need to do is actually come and export a few values with those values as well as your, for example, GitHub user and things like that. So what we're going to do here is just paste that section from the README. And what we're going to do is change your GitHub token to be that personal access token that we created at the beginning. We're going to change the client ID and client secret as well to be the same accordingly. And then for your GitHub username and your repo name, this is the repo that you have either forked or any other repo that you want to use as a GitOps repository that is going to be used by FluxCD that your user is a part of. So you can have a separate repo. It can be the same repo. It's going to go in a subfolder. So all is good. I recommend, just for the ease, you can just use the actual repo that you're working on here, and it'll just be in a subfolder. Obviously, in production, you're going to do this in its own repo. But basically, so we can see in my example, it's using vrabbi-demo, which is my user, and then there's this KubeCon NA 2025, so that's fine, and we're just going to use that same one here. So vrabbi-demo, and then your repo name is KubeCon NA 2025. Or was it 2025 NA? Yeah, that's right. Okay, awesome. With that, we're just going to export those variables quickly. So we're just going to copy that and run that in the terminal. And with that done, we're almost done here with the setup. It's just like 2 more steps. Once we have that, we're just going to run the rest of these commands. There's nothing else that we need to change. We just need to run steps 2 through 5, literally just copy them and paste them into the terminal. What this is going to do basically is we're rendering out our Argo CD manifest, which we'll get into in a moment what we're doing there, but we're using a mechanism called an application set in Argo CD. What that allows us to do is basically, based off of different generators, it's going to automatically generate the Argo CD applications for us. A really nice capability that Argo CD has. So we're going to be using that actually to generate applications on the fly for us throughout the workshop. And then we're going to basically template out our Backstage values with those different GitHub, based on those GitHub outputs that we had from before. And we're just going to Helm install Backstage, basically, with a custom image that we've pre-created into our environments. This is going to take a minute or two just to start up Backstage. So we'll give this a moment to run. While this is running, there are a few notes here that are kind of important. What you are going to want to make sure there is, when you go to the ports tab in VS Code, you can see that there is port 443 that is open. In code spaces, it gives you a public URL, basically, that you can use, but the visibility is set to private. For this workshop, because of some of the things we're doing, we have to just right-click on that line and change port visibility from private to public, and that's going to enable us some of the features that we need later on in the workshop. So that's just important to set up so that things work correctly. Basically, just so we can, while people are doing this, I'll give you guys a minute while Backstage is installing also. What did we actually pre-install here, right? What was going on during that setup? It is also important to note this setup has documentation to be run locally on your machines. So anyone that wants later on, this is an open repo, feel free to use it. It's part of the Backstack organization, and you can use this as a playground to test things in your labs and anything like that. What the initial setup script sets up is a kind cluster. So our environment is built up of a kind cluster. Inside of that kind cluster, we've installed Argo CD, we've installed Kyverno, Cert Manager, Ingress Nginx. We've installed Crossplane. We've also installed a bunch of sample Crossplane configurations, Kyverno policies, all ready for us to be able to do what we need to do in this environment. Typically, you're going to have a different URL for Argo CD and Backstage, I would say. In our use case, because we're running inside of a kind cluster and the beauty of how Ingress works within code spaces and things like that, and the uniqueness of projects that need to work on certain ports, everything is set up here with a subpath. So the same URL / Argo CD is going to take you to Argo CD, and just the URL on its own is going to take you to Backstage. So there's a bit of a weird setup in certain levels. We didn't want to make you guys do that and deal with the downloads on Wi-Fi networks of setting up Argo CD. helm install. It's really easy, right? Same thing with Kyverno, same thing with Crossplane, but all of the files for everything being installed is all here within these folders. So if you do want later on to take a look and see what the Argo CD configuration looks like, look at what the Backstage source code is that was built into the container image, you can see that all here within this repo as well. So it's not about hiding anything, it's just making sure that we can actually get done with the workshop in time. So with Backstage basically installed, we can come and just open the browser to this URL here. There's the URL. You can just click the globe icon or just copy it. It's going to open up in our browser, and you're going to get this warning from GitHub. Oh, it's a public URL opened up from a dev environment. Awesome. Yeah, we're using code spaces, so yes, and we're going to press continue. And from that point, security doesn't matter, and everything works. And welcome to Backstage. This is our Backstage instance, and what we're going to do is log in with our GitHub user. Press continue. Authorize the application, and we're logged into Backstage with our own users. This is hooked up, and it's working. With that, we're going to actually walk through the workshop itself now and really go over some of the use cases here in the end-to-end flows. So basically, if we go back to where this was in the README again, we went out to the relevant, hold on, apologize, one second. What we want to do is in the getting started guide, we basically want to go all the way down to the bottom, and then in this end-to-end flow demo, we just want to click follow the docs here. For anyone that doesn't get to that exact link, it's simply under docs. Hold on. Wi-Fi internet. We'll give it a moment, I guess. Come on, docs. Can't be that long. Okay, it's under the docs, and then there's the end-to-end flow there. I don't know why there's something weird going on with the internet here. But it's under docs, end-to-end, and then there is basically this lab guide here. And that's the guide that we're going to be following here. And basically, we're going to go through two different setups. We've done the setup, the environment. We're not going to do the explore around the environment, but anyone that wants to later can. And what we're going to do now is the actual workshop persona scenario. So we're going to start with the developer experience here. First, see what the experience we want to offer our developers is, and then let's look at how we extend this out as platform engineers. So the first thing that we're going to do is actually go and explore the catalog. If we go to Backstage, we can see we've already installed some composite resources into our environment. So let's take a look at one of these. For example, if I go to my clustered app or my web app, it doesn't matter which one. We're going to go into them here. Why? Conference Wi-Fi is awesome. And in a good situation, this is going to load. This is when you take your phone out and do a hotspot. Ugh. Hold on. Give it a moment. Maybe it'll work. But basically, what we will be able to see when it decides to load, Backstage is really fast, by the way. typically. But what we're going to get to see here in our catalog, we can see actually also throughout the docs itself, we've added in a bunch of print screens just to show kind of what this looks like. So while that's loading in the background, I'm just going to show you here also quickly, is once we log in and we get to our catalog itself, we have a bunch of different resources. And what we can actually start to see then is the actual components overview. And if we take a look at what a component looks like, we can see in this overview all of a sudden that here we have a section that tells us all of the details coming in from Crossplane. We can see that this is named my app, which namespace my composite resource is installed in. I can see the cluster this is installed into because Backstage allows us to connect any number of Kubernetes clusters to it. XRs, aka composite resources, aka claims rest in peace from Crossplane v1, can be namespaced or cluster scoped. So we're going to mention here which scope they are so that we understand that, because that's very important. There are two conditions that matter in the Crossplane world: synced and ready. Synced means the resource was applied to the cluster. Ready means whatever the target system is says that the resource is actually in a good state. Right? So that would be AWS coming back and saying the EKS cluster is ready, the EC2 instance is ready, something like that. That's when we'll be in a ready state. Synced state means it was applied to the cluster and all is starting the reconciliation. We then have how many managed resources are being managed here in the compositions. We can start to see Kyverno policy overviews, links, about data, right? We get all of this data available to us. Let's try again. Come on. Yay, it works. So we can see all of that same data here, right? We can even start going around some of these other tabs. We go to the Kyverno policy reports, and we can see here all the different data. We can see our different policies, and we can start looking also at our Crossplane data, for example, both in a graphical view. For any of these resources, I could click on them, see the YAML, see the Kubernetes events related with our specific entity as well. So we're going to get this full visibility. Now, that's great for a developer to get visibility. But how do they go and create a new service? So let's go and create a new service. So we're going to go to create here, and we're going to follow our guide. So when we go to follow the guide here, we can scroll down, right? This is the viewing of the resources. We've done all of that. That's great. And we're going to create a new application. So the first thing that we're going to do is we're going to select the app template specifically. And up here on the screen, we can see the data. We're going to use the name demo app 01 and the namespace backstack demo. Now, there is nothing preventing you from using different names, but all the commands below to make things easy use these names. And therefore, I strongly recommend using these names because otherwise you're going to have to manipulate a bunch of commands. So basically what we're going to do is go to our app template here, and we're going to use demo app 01. And this is backstack demo. And then we select the owner. Now, we haven't ingested any groups from something like Entry-ID or Okta or Active Directory or anything into the system or GitHub Teams, but you obviously would in a production environment. Here, you can select either guests or Kubernetes auto-ingested. Those are the two ones we have set up here. But we're just going to select that for now. And I'm going to select the image that I want, and we're going to choose Nginx directly. Nginx, no tags, anything. With that set up, we're just going to do next. We can select which composition we would want to use. As was mentioned before, we have the ability of writing different compositions. We can use different languages. You can later around look. We've implemented this specific composition in Go templating, in Patch and Transform, which is raw YAML, in Pythonic, as well as KCL. In this case, I'm actually just going to set it to runtime, though. It doesn't really matter. Let the system figure that out. And then the next thing is, where do we want to push this to? ClickOps does not mean no to GitOps. It simply means that what the clicking, when I click submit, that should push something to Git instead of kubectl applying it. And so that's what we're doing here. We are going to say, I want to target the demo cluster. If we had multiple clusters here, we could select that, and that's going to go into the relevant paths in our Git repo to be pulled down. And we're going to click Review and Create. This is going to basically render out a manifest for us and create a PR. I'm going to do Open Pull Request here. And just to save time, because Argo CD, Flux, any of them take time to synchronize because they're running on a polling interval, we're just going to merge that pull request. And while it's merged, and we wait for Argo to do its synchronization, we're going to come here and we can look at the files changed, and we can see that we've generated an application manifest here, but not an Argo CD application manifest. This is an app manifest, our custom app resource from Crossplane, right? The API that we have decided. We have a bunch of annotations here that are used by the Kubernetes ingester plugin within Backstage that are going to help these resources be auto-ingested back into the catalog. But we can see this is based exactly off of what we've had in our form. If I come back to the home page now within Backstage, we can see that we still only have those same components that we had looked at before. But let's head back to our docs now. And we can see that we filled everything out like we looked at before. And what we want to do is, what we want to do now is get the applications. Lord. What happened here to my screen? Hold on. Something happened here to the screen. 1 second. Jeez. Hold on. There we go. Oh, Wi-Fi at a conference. Woo! So, unfortunately, this is taking longer than we expected. But basically, this is going to auto-sync for us. And in a moment or two, we should see our new application pop up into our catalog in Backstage. Unfortunately, I will say we're going to get through as much of this as we can today, but the free environment on Codespaces should be good for about 8 hours of this running. You can shut down the environment afterwards, just stop it, and you can start it later and play with it and all of that as well if you want to continue. We still have some more time, but you can then shut it down and start it up later and just continue from where you were before. So just note that as well, which is important. Now, what we can do here is kubectl get application -a. We can see that we have an application that was automatically created for us. That new application we can see automatically synced here, demo app 01, and we can see the exact same experience that we had before is now in our actual terminal. But what we're going to do here, just because of the shortness of time, we're going to skip over some of the sides of the developer here. I want to jump over to the platform engineering perspective just for a moment to kind of go over what this experience is to add a new service to the environment. So let's go over that just real quickly here in the end-to-end flow of a platform engineer. And when we look at this here, I just want to, we're not going to do this necessarily. Anyone that wants to can follow along quickly. But basically, what we're doing here is saying, if I want to add a new service to my platform, this is what I want you to all take away from this, is how easy it is to add a new service here, right? We're basically saying, okay, I want to add a new service called database to my platform. And we're going to basically simply install it into our platform. Once we've done that, what we're able to do is simply create new XRDs, a new composition, and once I do that, it's going to automatically create that new software template for you, and allow you to maintain everything going forwards on your own. There is no extra maintenance that's going to go on. Everything that we're using in this workshop basically allows us to do an end-to-end flow of managing the life cycle of a service. One of the real powers here is that Kyverno traditionally is used as a tool that allows us to prevent things from happening. And that's great. Preventing bad things is a good thing, I hope. But another place that Kyverno can be used is actually as an amazing way of giving feedback to our developers. When we look here, I can see, for example, on this application we created, I have a failure. My developer sees directly when he goes to view his component that he's managing his application, I have a failure here. What is this failure? I've set the message myself saying validation error, Nginx image is not allowed, and it tells me which rule this failed on. Well, let's fix that. We can go to the scaffolder content. We can do choose. I'm going to do next and log in with GitHub. And with that, all that we need to do, obviously GitHub requires you to do 35 things in order to log in. But from there, we're just going to change the image from Nginx to, let's say, Nginx latest or any other image that isn't just plain Nginx. And when we do create, this is going to, again, allow our developer to never deal with GitOps, to never deal with YAML files, to never need to fill out YAML, but basically give them here. This is the form of the YAML schema with all of the values you have in Git right now. Go make your changes in the form, and it's going to submit a PR with those changes back to the GitOps repo, allowing ClickOps for day 0 as well as day 2. And that's what's really important. We're giving the UI front end through Backstage with the notification to the user and the feedback coming from Kyverno, powered by Argo CD, which is actually doing the real synchronization and allowing us to have that GitOps approach. And in the end, the reason it's so simple is because we have Crossplane, which gave us a simple API that our developer needs to fill out. The benefit of all of this is that if a developer wants to use a YAML manifest directly, they like YAML. I've heard there are people like that, and I heard there may be some of them here at this conference this week. They can take those YAML manifests and git commit and git push those directly to the GitOps repo, and you know what's great? They're going to show up in Backstage again, and the next person who needs to edit it can go to that, go to the update Kubernetes manifest, and update it from the UI as well. Meaning we can work in a symbiotic relationship, whether someone wants to work directly from the command line, someone else wants to work from the UI. Unfortunately, we're going to get everyone back on stage here just to kind of sum stuff up and to do a summary here. But I would love if people want to afterwards, find me. I'm here for the rest of the conference. In the evenings, anywhere where there is whiskey, that is where I will be found, basically. Not only in the evenings, but find me. Happy to always answer any questions on this stuff and play with this. This repo is part of the Backstack org. It's an org that we all really believe in, this idea of the Backstack, and we're looking for more contributors. So come play with it, test it out, give your feedback, and we'd love to work together as a community on building this new version of a platform. And with that, let's start out with the summary here. Yeah, sure. I'll start with Backstage. I apologize for you guys needing to listen to my voice for so long, but I'll finish quickly and then pass it on to the better voices here. Backstage really is a powerful tool. We didn't get to show here, but there's a part talking about the AI MCP integration that Backstage has, which is extremely powerful as well. I recommend people to play with that. But Backstage is the de facto standard, right? I've heard all of these questions coming around on, Backstage, it's so complex, it's so this, is it going to succeed, is it not going to succeed? The answer is Backstage is alive and well, and it is an amazing project with a huge trajectory going forwards. If you tried Backstage 2 years ago and got scared, so did I. try it again now. It is such a good experience now with the new front-end system and the new back-end system. Don't allow the misconception of how it was previously, where it was a real mess to deal with, prevent you from trying it again. It's in an amazing place now, and it is a great place to start. I personally maintain about 20 plugins, well, 27 to be exact, of Backstage. But you know, people should try them out. It's an amazing community. There is a Contrib Fest for that as well here. Yeah, and let's pass it off to Christian to summarize on Argo.
Yeah, so Argo, basically, to summarize what it does, right, it is a GitOps controller providing last mile deployment, right? So it's not a complete picture. It literally just takes care of deploying, managing the application YAML on your Kubernetes cluster, right? You're still going to need some sort of workflow in the beginning. So that really is the last mile kind of CD, continuous delivery, continuous deployment experience in a GitOps way. So.
And for Crossplane, we are the abstraction layer for your infrastructure and applications in a way that you can put your eggs in a basket in the Kubernetes reconciliation and declarative loop. It's declarative, consistent, allows for you to be flexible in the way that you need to do for your organizations and run it at scale.
And for Kyverno, very much summing up on the very last part that you saw there, it closes that feedback loop with your developer, makes it a lot easier for them. They have a guardrail there, they get some actionable feedback, and as you saw in the demo at the very end, that actionable feedback makes it possible for them to then fix what it is that went wrong without having to ask anybody, and automates all of your security, your compliance, your governance, as well as making it a much better developer experience for your team.
And if you want to get involved with any of the projects, we left GitHub repos for you to check out, for you to star if you really became a fan of them today. And then, of course, ways that you can continue learning about Backstage, Argo, Crossplane, and Kyverno. Backstage has a Discord server. Argo is over on the CNCF Slack. There's different channels for Argo components, and there's one for Argo CD. Crossplane has its own Slack at slack.crossplane.io. And then Kyverno is over on the Kubernetes Slack with Kyverno/dev. And there's also parties that we're throwing, so you can go to one of these 3 parties tomorrow evening. You can go to the Isovalent Hivemind Mango Crossplane.
Go to all 3 parties tomorrow evening.
You'll find us there.
With the whiskey, right?
A Crossplane graduation party or the Cube ATL Bash.
Exactly.
And with that, we'd like to thank you all for coming. Feel free to reach out if you have any questions, and thank you all for putting this together.
Enjoy the rest of the
you all.
conference. Yeah, awesome.
Have a good
Thank you.
time.
Thank you.